Example number 21. Find the equation of the tangent line to the graph of the given function at the given value of x. F of x equals the square root of x squared plus 15, and x equals 7. Well, if we're going to write the equation of any line, we're going to need a slope, and we're going to need a point. For our slope, since it's the tangent line, we're going to need f prime at 7. And for our point, we've got 7, and we have to find f of 7. So we'll start with the slope. If f of x is a square root function, the first thing we'll always do is write our square root with a 1/2 power. Then we use the power rule and the chain rule. So it's the power times the base to the power minus 1 times the derivative of the base, that's the chain rule part. So a little cleanup. I have a 2 on top that'll divide with the 2 on bottom. That's just going to leave a 1. And then I have x squared plus 15 to the minus 1/2 power times x. Since that's a negative exponent, I'll move that base, x squared plus 15, to the denominator. And since I'm going to have to evaluate it, I'm going to write it back in the square root form. So the equation for the slope of my tangent line is x divided by x squared plus 15. This is the formula to find the slope, the tangent line. So I have to find f prime at 7. So it's going to be 7 divided by the square root of 7 squared plus 15. That's going to be 7 over the square root of 49 plus 15. That's going to be 7 over the square root of 64. So my slope is actually 7/8. So this is the slope that I'll use for my tangent line. Now remember, we also have to have a point. So we've got to find f of 7 so that we'll have the y-coordinate of the point. So for this one, we're going to put it in the original. So 7 squared plus 15 to the 1/2 power, or square root, is the square root of 49 plus 15, which is the square root of 64, so that's an 8. And so my point that I'm going to use, since f of 7 is 8, is the point 7/8. So now I have to write an equation of the line with a slope of 7/8 that goes through the point 7, 8. So the equation of a line is y equals mx plus b. I like this format because it's solved for y, and that's usually the format that my math lab asked for. You might recall y minus y1 equals m times x minus x1, and that will give you the same result, but you'll have to solve it for y. I'm just going to substitute the y that I know is 8, the m that I know is 7/8, the x that I know is 7, and I'll go ahead and put that over a 1 to keep those numerators and denominators lined up, then plus b. So 8 is 49 over 8 plus b. And to get b by itself, I have to subtract 49 over 8 from both sides. So b is going to be 8 over 1 minus 49 over 8. Doing this manually, I can multiply to get a common denominator. So I need an 8 denominator, so that's going to be 64 over 8 minus 49 over 8, which is going to be 15 over 8. That's my y-intercept, my b value. So that's 15/8. And now writing the equation is easy. It's just y equals the slope times x plus the b value. So our answer for the equation of the tangent line to that function at the x value of 7 is y equals 7/8 x plus 15/8.